Hello all, myself Mrs. MAKangale. I welcome you all in the session of ninth geometry. Today's topic is quadrilaterals. Let us see a theorem on quadrilaterals. The statement of the theorem is prove that the diagonals of a rhombus are perpendicular bisectors of each other. Here we have to show that the diagonals of rhombus are perpendicular bisectors of each other. For that, we will draw a rhombus and its diagonals. Here the quadrilateral ABCD is a rhombus and the diagonals AC and DB intersect each other at point O, and we have to show that the diagonals AC and DB are perpendicular bisectors of each other. So let us write down the given and to prove. Given that the quadrilateral ABCD is a rhombus and we have to prove that its diagonals AC and DB are perpendicular bisectors of each other. Let us go for the proof. As the quadrilateral ABCD is a rhombus, it is a parallelogram too. So, by the property of a parallelogram, the diagonals of a parallelogram bisect each other. Therefore, we can say that the diagonal AC and diagonal DB, they are bisecting each other. That means this OD is equals to OB and the segment AO is congruent to segment OC. Let us write down it and we will call it as equation number 1. Now we want to prove that the diagonals are perpendicular to each other. To prove this, let us consider the two triangles, triangle AOD and triangle AOB. In these two triangles, we will show the two triangles are congruent to each other. If the two triangles are congruent to each other, the angle AOD and angle AOB, these two angles will be congruent, but they form a pair of linear angles, and as they are linear angles, their sum is 180 degree and the angles are congruent. So we can say that each angle is of 90 degree, which shows that the AO is perpendicular to DB, or we can say that the AC is perpendicular to DB. And already we have shown that AC bisects DB, and now we will prove AC is perpendicular to DB, which combinedly can be said that the diagonals are perpendicular bisectors of each other. So let us go for proving the two triangles are congruent. Consider the triangle AOD and triangle AOB. Segment AD is congruent to segment AB, as these are the sides of rhombus. Segment DO is congruent to segment OB. From equation number 1, we have already shown here. And segment AO is congruent to segment AO, which is a common side. Therefore, the triangle AOD is congruent to triangle AOB by SSS test. Now we have shown the two triangles are congruent. As the two triangles are congruent, we will go for the next part. The angle AOD, this angle is congruent to this angle AOB. As the two triangles are congruent, we can say that the two angles are congruent by CACT, the corresponding angles of congruent triangles. Now, as the two angles are congruent and these two angles are forming a linear pair, we can write the triangle AOD and triangle AOB are linear pair angles. Therefore, they are supplementary. Therefore, we can write angle AOD plus angle AOB equals to 180 degree. And we can write it as 2 times angle AOD. Since angle AOB is congruent to angle AOD, instead of AOB, I will write AOD and we can write it as the sum of two angles, 2 times angle AOD Divide the complete equation by 2, which gives us angle AOD equal to 90 degree. And it shows that the angle AOD and angle AOB are right angles as both are congruent. We will call it as equation number 2. From equation 1, the diagonals bisect each other, and from equation 2, we can write the angles are right angles, which shows that the diagonals of rhombus are perpendicular bisectors of each other. Thank you.